Hello again. Today the lesson is integration by reduction formula. Integration of reduction formula is used when we have an unknown power so that we can establish a recurring relation that can help us to establish or to find the integration. So this means that knowing the integral Im the integral Im, this means that we have the coefficient of m in the integrand. We can establish the general relation, the general relation by integration by part that will help us to establish or to find em negative 1, em negative 2 till e2, e1 and e0. Let's see example and I will explain clearly using examples. Number 1. Let em equal to x power m e power ax dx. This means that this index m is related to this m, the power of x. So when we put x0 here, we will get e0, which is equal to integration of x power 0 e power ax dx. Number A, show that aem plus mem negative 1 is equal to x power m e power ax. Number B, we have to deduce the value of e0, e1 and e2. So let's see how we can collect this example. So we have em, which is equal to integration of x power m e power ax dx. By using integration by part, we have to divide this integrand into two parts such that what we call u can be easily differentiated and what you call dv can be easily integrated. So can see that this is exponential, this is a polynomial. So by using Liat, can write u equals to x power m. This means du is equal to m x power m negative 1. property of differentiation or derivative. Can call dv, this is u and this is dv. dv is e power ax dx. This means the v is equal to integration of e power ax dx, which is equal to 1 over a e power ax equal ax plus c. So can write, since em is equal uv negative integration of v du, em is equal to u times v, which is equal to x power m divided by a e power ax negative integration of v du. v du, this is m x power m negative 1 times 1 over a e power ax. Here we have dx, put dx here. So can put out of bracket this m over a, and I can write x m, it is equal to m x power m e power ax divided by a negative m over a integration of x power m negative 1 e power ax dx. So we called this em because the power of m here. So we can call this integration as em negative 1 because the power of x is m negative 1. So this is the em negative 1. So I can write em to be equal x power m e power ax over a negative m over a em negative 1. So remember that we have to show this equivalent or this reduction formula. So in order to get this, you can see that I have m here, a here. So since these denominators are the common or are the same, I can write one of them and put on the common denominator. So I can write em equals to x power m e power ax negative m em negative 1 divided by a. So I can multiply this m here so that I can get aem is equal to x power m e power ax negative m em negative 1. So to get the requested formula, I have to move this em negative 1 here so that I can get aem plus m em negative 1 to be equal to x power m e power ax. This is the equivalent we want to show. So this is how we can prove this reduction formula from the given integration containing the power of m. So this is a, and b, we have to deduce e0. So we we have seen that em is equal to integration of x power m e power ax dx. This means that e0, this means that m is equal to 0. M is equal to 0. I will get integration of x power 0 e power ax dx. This means that e0 is equal to integration x power 1 is equal to x power 0 is equal to 1 e power ax dx. We don't, we are not going to integrate this as we have integration relation. So when we want to get e0, we will replace m equal to 0 in this expression and then get the value of e0. So since m is equal to 0, I have a, by replacing m here, I have a e0 equals to plus 0 times e0 negative 1 equals to x power 0 e power ax. So here we get 0 because this is 0 times e negative 1. That will be 0. I will get a e0 to be equal to x. This is 1. This is e power ax. And finally e0 is equal to 1 over a e power ax equal to 1 over a e power ax. So this is e0 and e1. We replace e1 here, m equal to 1 here. I will get e1 equal to integration of x power 1 e power ax dx. So here I'm not going to integrate this, but I will replace m equal to 1 in this expression to get e1. So by replacing here, I will get a e1 plus m e1 negative 1 equals to x power 1 e power ax. So you get a e1 plus, sorry, here I have 1. This is 1 e0 equal to x e power ax. So I will finally get a e1 equal to x e power ax negative e0, and e0 is equal to this one. So I will get e1 to be equal to x e power ax negative 1 over a e power ax. So I can get finally e1 equals to 1 over a bracket of x e power ax negative 1 over a e power ax. This is the value of e1. So for e3, e2, I will replace m equal to 2 here. I will get x power 2 e power ax dx. By replacing m equal to 2 in this expression, I will have a e2 plus 2e 2 negative 1 equal to x power 2 e power ax. So I will find e2, which will be equal to x power 2 e power ax negative 2 e1. So negative 2 e1 divided by a. So e2 will be equal to 1 over a bracket of x power 2 e power ax negative 2 times. I can multiply this a inside, so that I can get 2 x e power ax over a negative, by multiplying this minus here we'll get this minus, and here we get plus 2 e power ax over a square. So e2 will be equal to, by multiplying this a inside, I will get x power 2 e power ax over a then negative 2x e power ax over a square plus 2 e power ax over a cube. This is the value of e2. So now this is the first example. Let's go for the second example. The second example is saying that this is number 2. Given that em equal to integration of x power m Rn x dx, we have to show that em plus 1 times em is equal to x power m plus 1 Rn x negative 1 over m plus 1. So number B, we have to deduce the value of E0, the value of integration, the value of Rn x dx, and integration of x Rn x dx. So now let's find the solution of these questions. Number A, we have em, which is equal to the integration of x power m Rn x dx. So we can see that this is logarithmic function and this is the polynomial. From the word Liat, we relate this u and this one will equal to dv. So u is equal to Rn x du is equal to 1 over x, dv is equal to x power m dx, and v is equal to integration of x power m dx which is equal to x power m plus 1 divided by m plus 1. So I can write the given expression as em equals to uv equals to uv equals to uv uv is equal to x power m plus 1 over m plus 1 Rnx negative integration of v du this is integration of x power m plus 1 divided by m plus 1 times 1 over x dx. Can simplify this, so I can have em equal to x power m of m plus 1 Rnx negative integration of x power m over m plus 1 dx. Can have this as x power m plus 1 over m plus 1 Rnx negative 1 over m plus 1 times x power m plus 1 over m plus 1. So I can have em to be equal to x power m plus 1 over m plus 1 Rn of x negative x power m plus 1 over m plus 1 square, the multiplication of this and this. So in order to get the asked equivalent or identity, I can see that I can factorize 1m plus 1 1m plus 1. So I can write as 1 over m plus 1 bracket of x power m plus 1 I can multiply here x by m plus 1 bracket of Rnx negative 1 of m plus 1. So I can multiply this m plus 1 here so that I can get m plus 1 em will be equal to x power m bracket of Rnx negative 1 over m plus 1. This is the required identities. For number B, I have to deduce. I have seen that m plus 1 em is equal to x power m plus 1 bracket of Rnx negative 1 over m plus 1. Integration of Rnx dx is equal to E0. Is equal to E0 because E0 is integration of x power 0 Rnx dx. This is 1, and we will get E0 equal to integration of Rnx. So can deduce this E0 from this formula by putting m is equal to 0. So we will get 0 plus 1 is 0 equal to x power 0 plus 1 times Rnx negative 1 over 0 plus 1. I will get here is 0, which is equal to x bracket of Rnx negative 1. This is 0. and we are asked to deduce integration of x Rn x dx, which is equal to e1 by replacing m x equal to m equal to 1 in the expression en equals to integration of x power n x power m Rn x dx. I will get en e1 to be equal to integration of x power 1 Rn x dx, which is equal to integration of x Rn x dx. So we have to replace m equal to 1 in the given recurring relation to get 1 plus 1 e1 equal to x power 1 plus 1 Rn x negative 1 over 1 plus 1. So we have 2e1 to be equal to x power 2 Rn x negative 1 over 2. So e1 will be equal to e1 will be equal to e1 will be equal to 1 to x squared over 2 bracket of Rn x negative 1 over 2. This is the solution of the second example. So thank you for watching.